Welcome back, everybody. Today we will be talking about RE4, zero and negative exponents. Our objective today is that you will be able to simplify zero and negative exponents. The way we're going to start with today is we're just going to start looking at the values produced by just raising 2 to a set number of powers, right? So our calculator might be of assistance for this for us. Some of these we'll know on our own, but let's take a look. So if I had 2 to the 4th power, I would get 16. So 2 to the 4th, we could say is 16, right? Then let's go to 2 to the 3rd. So if I take 2 and I raise it to the 3rd power, we know that this is 2 times 2 times 2, which is, of course, 8. We get 2 to the 3rd is 8. And then I get to 2 to the 4th. Or I'm sorry, not 2 to the 4th, 2 to the 2nd. Jumping ahead. 2 to the 2nd is just 2 times 2, and we know that that is, of course, 4. Now, from there we get to 2 to the 1st, and that's maybe where in our heads it gets a little odd. So let's just look at this for a second and see if we can notice what's going on. 16, 8, 4. Oh, I think I see a pattern, right? So the pattern maybe that we start to pick up on is to get, that wasn't right, to get from 16 to 8, maybe we notice that we're just dividing by 2, right? 16 divided by 2 would give us 8. And if this is really a pattern in math, we know that patterns exist in math a lot. Maybe that works for the next one. So if I take 8 and I divide that by 2, 8 divided by 2 gives us 4. That also makes sense to us. So maybe if I follow the pattern down and I divide by 2 again, I can get to that next number. Now, if I take 4 and I divide that by 2, I know that that gives me an answer of 2. But like maybe we're not exactly sure, so let's just put a question mark there for a minute. We can check it using our calculator. So 2 to the 1st power, in fact, is 2. So it does look like this pattern actually works, and we can generate what comes next. Now, let's just follow this pattern down some more. So if I were to divide by 2 again, 2 divided by 2, well, we know any number divided by itself is always equal to 1. But wait a second, this looks a little funny. 2 to the 0 power equals 1. Just intuitively, that doesn't seem to make a lot of sense for us. We can use our calculator, though. Let's try to check this out. So if I take 2 and I raise it to the 0 power, 2 to the 0 power, it looks like, in fact, we do get 1. So our pattern has proved to be right, or at least that's what our calculator is telling us at this point in time. So let's go along with it for a second. Now, negative exponents, we haven't seen those yet. 2 to the negative 1. Well, let's just punch that in for a second on our calculator. 2 to the negative 1 power, we get 0.5. And I don't like decimals a lot, so I'm going to change that into a fraction. We know that 0.5 is really just 1/2. Now, did our pattern stop working, right? So if I take 1 and I divide it by 2, I actually get 0.5 again, so our pattern must still be working, right? So we can still divide by 2 here. Okay, so that's good. So our pattern seems like it's working pretty well, but it's still a little odd, the numbers that we're getting. 2 to the negative 1 is 1/2. Well, let's see what 2 to the negative 2 is. So if I take 2 and I raise it to the negative 2 power, that's 0.25. Now, we could write 0.25 as a fraction, and we could write it, I'm going to save a little space here, as 1/4. We know that 0.25, right, is 1/4. And in fact, if I actually take, so let's try this out now. If I take 1/2, that's what I got for my last answer, and I divide that by 2, does our pattern hold up? And we get 0.25. It does hold up. So divided by 2 again works. That's good. All right, so I think I'm starting to maybe see what's going on here. If I take 1/4, right, and I divide that by 2, so 1 divided by 4, divided by 2, we're just following that pattern down, we get 0.125. Now, maybe we don't know exactly what that is as a fraction, so we could maybe use our calculator to help us. So if I look at the fraction value of that, I get 1/8. So this ends up being 1/8. Now, whenever we're kind of discovering stuff like this in math, we should always be going back and trying to check as many ways as possible so we don't just get going on a wrong path. But if I were to look at 2 to the negative 3 power, I do get that 0.125, right? So we're seeing the same thing showing up here and here, telling us that, yeah, we are getting the same answer, right? That would also be 1/8. Now, this is just a typo, it looks like at that point. That's fine, because it's just the same one we had already. Now, let's think about this for a second. Can we rewrite these in a way that maybe makes a little bit more sense to us? And I think we can, because isn't 4 just really the same thing as saying 2 to the second power? And if I look at 8, according to my list up here, 8 is really the same thing as just saying 2 to the third power. And maybe we start to see a pattern here. I mean, I'm looking at this pattern. The negative exponents are kind of what are creeping me out the most right now. So if I have a negative, something raised to a -2 power, it looks like if I just move this whole thing to the bottom of a fraction, that power becomes positive. And at that point, we know we're really good actually at working with positive exponents at that point in time, right? So maybe that works for 2 to the -3 too, right? If I move that whole term to the bottom of the fraction, it becomes positive, and then we can kind of start to work with it again. So we're starting to kind of develop just a set of rules that work with negative exponents, and we also had this extra rule in the middle here that dealt with something raised to the 0 power. Now, in fact, we could actually repeat this in math with any number. We could take 3 and raise it to all these different powers, and we're going to start to see these same patterns start to exist in a little bit more depth. Now, instead of just going with nice numbers, let's try to do this with some fractions. Right? These definitely aren't 2 raising it to a power anymore. Now, we could start on this list wherever we want. I think I'm going to use our calculator just to help guide our thoughts here a little bit. If I had, now this is important, folks. If you're going to sit there and try to type this into your calculator, I really need you to be using parentheses. Otherwise, we're not going to be getting the right answers. So if I had 3/2 and I raised it to the third power, we could evaluate this by hand, or we can use our calculator to do some of the lifting. This is what we get. Okay. Wow, that wasn't quite what we were looking for, because now even if I turn this into a fraction, let's see what we get. Oh, that actually helps us out. 27/8. So 3.37 turns us into 27/8. And, well, yeah, of course, because the 3 goes here. 3 to the third power is 27, and 2 to the third power is 8. Now, if I had 3 to the second power, wouldn't that just give us 9? And 2 to the second power would give us 4. So we're starting to develop these same rules again. Okay, 3 to the first power, well, maybe we're not sure quite, but if I took 3 to the first power, that actually is just 3 still. And if I took 2 to the first power, that would still give us 2, right? So we're starting to develop this pattern that goes along. Now, so far, we've actually practiced working on these yesterday, so we're pretty good at these right now. This one, like, maybe we're a little bit newer at this one, right? Raising something to the first power. We haven't really gotten into that too deep. But it does look like that if I raise anything to the first power, it just ends up being itself. And that's kind of unique. Let's see what happens with 3/2 to the 0. Now, I'm not even going to try to guess what happens here. I'm just going to type it into my calculator and let it do the work. 3 divided by 2, raised to the 0 power. When I hit enter, let's see what happens. We get 1. Okay, now that's seeming odd. Maybe let's go back and check what we did last time and see what we got. So when we had it to the 0 power up here, it was 1, 2. Okay. So that seems a little suspicious, but we're going to keep going on. I'm going to put a question mark next to that one because that's kind of like one of the new things we're trying to tackle today. So I just want to keep that kind of on the front of my mind. I think we're probably feeling good about these top 2. That maybe makes some sense to us, but oh my gosh, here's some negatives. I'm going to put a question mark next to these to begin because that's kind of our focus for today, actually. Now, okay, let's see about this for a second. So if I had 3, let's use my parentheses, over 2, raised to the negative 1 power. And if I just make that into a fraction, 0.66666, maybe we know that that's already 2/3, but this ended up being equal to 2/3. I'm going to put it over here because I want to think about this a couple different ways here. Okay, 2/3 is what that really ended up being equal to. Okay, let's try that for the next one too. So if I had 3 divided by 2, and I raise that to the negative 2 power, 0.44444. I'm not familiar on the top of my head, so I'm going to use my calculator to do some lifting. I get 4/9. Okay, and 3 divided by 2, and if I raise that to the negative 3rd power, I get, well, that's just 8/27. Okay, so wait a second. I think I saw some of these numbers already, but they look different. Now, if you look at this guy right here, that one we were able to actually do by hand. And if you look at this guy, do you notice how they're just reciprocals of one another? They're just flipped fractions. And the only thing that was really different when we started was just that was a 3 and that was a positive 3. So it looks like whenever I have a negative exponent on the outside of a fraction like that, it looks like I can maybe even just start by just flipping the fraction. And if I just flip the fraction, it looks like I just raise it to the 3rd, raise it to the 3rd, 2 to the 3rd is 8, and 3 to the 3rd is 27. Okay, let's see if that works for previous problems. So if I had, well, I see a negative exponent on the out. What if I just flip this whole thing right now? Think about it as positive, and then if I did that, 2 to the 2nd would be 4, and 3 to the 2nd would be 9. I think we're on to something, guys. Okay, what about up here? So, again, if I see a negative exponent, let's just flip that whole thing for a minute. And make that positive. Okay, so going through with that, 2 to the 1st is in fact 2. That is true too, and 3 to the 1st is 3. I think we're figuring out this pattern a little bit, and that's good. Now, there's other ways to think about this pattern as well, and we're going to start diving into that, but before we do, I want to show you a couple of really big ideas that we want to be familiar with. The first idea we want to be familiar with is this idea that we started to talk about when we were looking at those powers of 2. And what those ideas kind of told us was that anytime I have something raised to a negative power, if I just move whatever that something is to the bottom of a fraction, that power becomes positive and we can deal with it like we have been. The second property we talked about is that whenever I have something being raised, sometimes we can actually just flip the A and the B together, right? We just switched. The A went to the denominator and the B went to the numerator. And then when we distribute that exponent out, they're positive again. I think we're going to need some practice on this, but we'll get going here. That's maybe okay. Big idea number 2. Anytime you have a number, right, any number is raised to the first power is itself, right? Any number raised to the first power is itself. So right here, if I see x, x could be thought of as any number. If I raise it to the first, that's just equal to x. 5 to the first is equal to 5. It's kind of a boring property, but it's an important one at the same time. The last property, and this is kind of what I was thinking, if I have any number and I raise it to the power of 0, it's always going to be equal to 1. So if I have x to the 0 power, it's going to be equal to 1. If I have 5 to the 0 power, it's going to be equal to 1. If I had, let's make the most complicated math idea we could, right? If I have the integral of 3 and 2, and I want that as x to the 5th, and I take this whole thing, you don't even know, that's a calculus idea right there, ladies and gentlemen. But if I raise it to the 0 power, you know what that's equal to? 1. Anything raised to the 0 power in math is always equal to 1. And to be honest with you, it's not an idea that makes a lot of sense in our heads. Often I see kids that want to say, well, it's 0 block. But that's not true. Anything to the 0 power in math is equal to 1. Now, that's a free answer for you on any test or quiz that you get because we're going to try to trick you on stuff. But if it's raised to a 0 exponent, make it equal to 1 and move on with life. Now, I think we're going to make 2 videos to go through this one. Part 1, we're going to go through and do all the problems in this left-hand column. So we're going to get some practice right here. And then for part 2 of the video, I'll come back and I'll do the other half. So let's just go through for part 1. Here we go, lots going on. So let's start simplifying this. So I see parentheses, right? Remember that PMME idea we were talking about? Parentheses mean multiply exponents. We're going to put our extra exponents in like we have been doing all chapter. And now we can multiply the 3 to each of these. Now what I want you to remember about this, ladies and gentlemen, is that our base isn't going to change. Only our exponents change. So we're still going to have a 2. We're still going to have an x. We're still going to have a y. The powers on those are going to change though. So 3 times 1, let's just even highlight it. 3 times 1 is going to give us a 3 as our exponent. If I do 3 times 1 again, I'm going to get another 3. And if I do 3 times negative 2, I'm going to get a negative 6. Wonderful. We've done a lot of good work there, but we're not quite done. Now, one thing that we're going to talk about today is negative exponents. In our problems, we don't ever want to see negative exponents because as soon as we start to see them, our brain goes, whoa, there's an issue here. I don't know how to work with that. I know how to work with it if it's positive, but I don't know how to work with it if it's negative. So we're going to work on changing negative exponents into positive exponents. Now, if I take 2 to the 3rd power, we can just make that into 8. We know that because that's 2 times 2 times 2. We get x to the 3rd power. And now I have y to the negative 6. Now I'm going to show you a trick. This is how I like to deal with them. Anytime I see a negative exponent, I like to take my whole expression and turn it into a fraction. And we can do that in math all the time. We make any number into a fraction by putting it over 1. Then what we're going to do is we're going to take the part with the negative exponent, and if I move it to the other side of my fraction, it becomes positive. So if I move that y to the negative 6 to the bottom, now it's going to be y to the positive 6. That's how we are going to be dealing with negative exponents. Now up top, these two didn't have negative exponents, so they're just going to stay up here like so. Nice work. Let's look at the next one below that. Here's another one for us. So we have 3y to the 5th, all raised to the 2nd power, times y squared. So again, we see parentheses. So we want to move that 2 to each of those exponents, right? Parentheses mean multiply exponents. So the bases are not going to change. I'm going to have 3 to the 2nd power and y to the 10th power. And that's going to be times y to the 2nd power. Now, as we look at this, ladies and gentlemen, please notice that we have 2 stacks of y's. We have y to the 10th right here and y to the 2nd. Those 2 things have the same base, so we can put them onto the same pile. And on that pile, we're going to have y to the 12th. Now, 3 squared is, of course, just 3 times 3, which is 9. So that is another way to write it. Sometimes you're going to see it written as 3 squared. Other times they'll change it to 9. But we want to be familiar with both. Great job. Let's move on to the next one. All right, so this one I see a negative exponent right away, and that's okay. We don't need to worry about it right off the bat, but at the end of the day, we want to make sure that our answer does not have negative exponents in it. That's not okay to have a negative exponent in the end. So we're going to start by just multiplying 4 times 2. Remember, in any of these problems, if we're just multiplying, those coefficient values can just be multiplied like we have always done. So we'll have 4 times 2, and that's going to give us 8. Now, taking n to the 4th and n to the negative 3rd. Now, those are just 2 piles of n's, and we just want to put them on the same pile. So if this pile had 4 things and this had negative 3 things, when I add those exponents together, right, 2 things have the same base being multiplied, we add our exponents, we're just going to be left with only one thing, right? 4 plus a negative 3. That's our exponent. would just be equal to n to the first power, making this our final answer. Let's keep moving along. Here's our next one. All right, we see that big negative exponent on the outside, but we also see parentheses. So let's use our PMME, parentheses, mean, multiply, exponents. Let's multiply our exponents together. Before we can do that, let's make sure our 2 has that exponent on it. Now it makes a little bit more sense maybe why that's a 1 on there after talking about our stuff today. And then we're going to multiply our exponents together. Now, we already know our bases aren't going to change, so I'm still going to have a 2, an x, and a y. Our powers on those, our exponents, are going to change though. So if I take -1 times 1, I'm going to get a -1. If I take -1 times 4, I'm going to get a -4. And -1 times a -3 actually gives us a +3. Now, as we look at this, what I told you before is no answer is finished if we have a negative exponent. So what we need to do is we need to be able to fix those. The way we're going to fix those, my secret, is to sit there and turn it all into a fraction. Start by turning it or putting it over 1. By doing that, then your brain starts to trigger and say, oh yeah, this is a fraction. I know I can pull negative exponents to the bottom. Why didn't we have to move the y to the third to the bottom? Because it was positive. If I have a positive exponent, we don't need to move it. It's not just flipping the whole fraction, it's flipping the pieces that need to be flipped. So, my new fraction, this y to the third here did not get moved. It had a positive, so that stays on top. On the bottom now, when this 2 to the -1 comes to the bottom, what's going to happen with our exponent is it's going to become positive. When my x to the -4th moves to the bottom, it's going to become positive. That's why we moved it to the bottom, because we don't want to deal with negative exponents. Now, of course, we do know that anything raised to the first power, right, like this 2 is, anything raised to the first power is just itself, so we can get rid of that 1 if we choose, which would make this into our final answer. Nice job. That was a tough one. Let's keep going. Do you see it already? I hope you do. Remember, all of this inside here is being raised to the 0 power. And if we go all the way back up to our rule up top, we know that any number raised to the 0 power is equal to 1. This is a number, right? Whether we believe it or not, this is just a number. And any number raised to the power of 0 is equal to 1. And we are done, ladies and gentlemen. We don't need to work any harder than that. Now, some people might look at that and they might say, well, there's parentheses there. We should do PMME. And we can. If I multiply 0 times 3, though, I'm going to get 0. And if I multiply 0 times -3, well, it's -3 on both, I guess, I'm going to get 0 again. And remember, anything raised to the 0 power is equal to 1. So that becomes 1. And that becomes 1. And 1 times 1 is, of course, 1, which we already got. Right? So there's multiple ways to attack these problems, and we're looking for the easiest sometimes, and that's okay. Looks like this might be our last problem of our part 1 video. Again, after this, I'll make another video of a part 2, and then we can come back and practice more if we need it. So 5x over 3yz all raised to the -3. So first thing in my brain I'm thinking is I see parentheses. That's where I like to go with my PMME. Parentheses, mean, multiply, exponents. Now inside, do you notice how we didn't have any exponents? That means all of these need to have a 1 put to them. And I'm going to multiply this 3 all the way through. So this -3 is going to go to a lot of different places. Now, since there were no exponents, 1 times negative 3 is always going to be negative 3. So my new expression will be 5 to the negative third, x to the negative third, over 3 to the negative third, y to the negative third, z to the negative third. A lot of negative 3's there. Okay, we got to start digging into this because this is anxiety provoking. Here's how we're going to do it. Now this one's already looking like a fraction, right? And what we've already learned is that if I ever have anything with a negative exponent, I can pull that single piece to the other side of the fraction and it's going to become positive. Now we've only ever had to pull stuff down to the bottom, but on the bottom, do you notice how we already have negative exponents down there? So we're going to actually take these to make those positive. We're going to move them all to the top. So in this situation, since everything had a negative exponent, our fraction is literally just going to flip, and all of our exponents are now going to be positive. So let's break that down slowly. When this 3x to the negative third, when that moves to the top, it's now going to be positive, or I'm sorry, it's going to be 3 to the positive third power. When y to the negative third moves to the top, it's going to be y to the positive third. And when z to the negative third moves to the top, it's going to be z to the positive 3. What moving it to the top or to the bottom does is it just makes that exponent positive. Now, on the bottom of this, when 5 to the negative third went down, it became 5 to the positive third. And when x to the negative third went down, it became x to the positive third. Now, we always want to look to see if there's any variables that are the same on the top and the bottom. And I think that's going to come up in RE5, where we're going to look at that a little bit more. But right now, we're done. There's nothing we could cancel. This is looking good. I would say the only place we could pretty this up a little bit is if we looked at what 3 to the third is, because we can figure that out on our calculator. 3 to the third is just 3 times 3 times 3, and we get 27. So I'm going to have 27, y to the third, z to the third. And then on the bottom, I'm going to get 5 to the third, which is 125, and I'm going to have x to the third power. And that's it. That's as good as we can make that thing look. So let's review very quickly. Again, part 2 is going to be coming up next, so if you need a little bit more practice or just want to see some more problems, you'll find that there. These were our super huge ideas for the day. We first started talking about how negative exponents are not okay. If we have negative exponents, we always want to move them to the bottom of the fraction or to the top, because switching the side of the fraction that they are on makes that exponent positive. Our second big idea of the day was that if anytime I have a number that is raised to the first power, it's always just equal to itself. That's pretty intuitive, I think. And our last idea is that any number raised to the 0 power is equal to 1. I don't want to see anybody get that one wrong. That is a free question for you. You just got to think about it, right? If it's raised to the 0, don't do what your brain tells you. Your brain's going to say it's 0. It's not true. Anything to the 0 power is equal to 1. If you guys have any questions, please make sure you're talking to your teacher. Thank you for watching this video. Have a great day.